Hello and welcome back to the part 2 of our Quadruped Motion Matching tutorial series. So in our part 1 we have set up our animation blueprint and we have set up the motion trajectory. So in this part we will set our practical example for our motion matching. So what I'm gonna do is go to my content browser. I'm gonna create a new folder for my schemas and a new folder for my databases. There we go. So for schemas, I'm gonna go to animation, motion matching, pose search schema. Sorry, schema. I'm gonna go to animation, motion matching, pose search schema. We need to select our skeleton. Pose search schema underscore default. Quadruped default. This is our default schema. So what are the schema, what are all the properties? So I'm not gonna go into details. I have already covered all these things in my breakdown motion matching tutorial series. So if you want to guys learn more about what are all these properties, how we can use these, I have already explained in other tutorials. So in this one I'm gonna go with the only things which I have changed, which I have set up for this motion matching to work. So I have set this up data preprocessor to normalize with common schema, and in order to debug what is happening with this what is pose search schema, I'm gonna go to my database and create a database first. So in motion matching, pose search database, and for my I'm gonna select my pose search schema, pose search database underscore Locomotion, or let's say call it quad movement. This is our quad movement. So the most important thing here is selecting the animation. So make sure your animations have root motion enabled. So like we can have in place animation, like inside this folder we have in place animation. Motion matching cannot work with these. So in order to motion matching to work, make sure your animations have root motions. Like if I select this animation, Locomotion walk, we can see our animations have this root motion enabled. And also the important thing is, while working with these animations which are like a shorter length, see our animation is like 1 second. So in order to work with these animation, make sure you set your animations to looping. So I'm gonna select all my animations, go to set action and change the properties at once. So make sure your animations have the looping enabled if your animations are shorter length, and set your enable root motion to true, force root lock to true as well. There we go. So now if I search for walk, loco walk, place it over here. Let's just set up our schemas. First I'm going to set it to 1. I'm going to close this to database, quad database, loco walk. This is not appearing, the animation is not appeared. Why? Just a moment. Sometimes the animations are not appearing in the viewport. So I'm gonna open my schema. So let's just set up our schema first. So first thing is data preprocessor. That is to normalize with common schema. I'm gonna add a, so for trajectory channel, first thing is our trajectory channel. I have set this weight to 1, and I'm gonna use 5 samples for my trajectory. First will be at -0.05, because as I mentioned we are working with shorter length of animation, so I'm gonna set the samples to like really close, 0.05, 0.1, 0.3.5. So I'm gonna set this to 0.05 first one, second is at 0, third will be set the weight to 1. Third will be my at point 1, set the weight to point 1, set the weight to 1. Fourth will be my at point 3 second, weight to 1, and fifth will be my at 0.5 second and set the weight to 1.5. There we go. Just a moment. For the last 1.5, I'm gonna set this to velocity direction. Instead of position, we will set it to velocity direction. So these are our samples. So if you want like more details, what are these samples, I have already covered in my breakdown motion matching tutorial series, so I will not go into details. So here we have our 5 samples for our trajectory. The next thing is I'm gonna use a group channel. That group channel will contain my position for different bones. Like I'm gonna use my two forward leg, backward leg, like position of 4 legs and the velocity of my pelvis bone, so that I can blend from walk to run to trot based on my pelvis velocity, like the pose can properly blend. So for the second channel, I'm gonna add a group channel over here. The group channel will contain, first sub channel will be my position channel. Position channel, there we go. I'm gonna set the color to, let's say, for green. So if I open my, let's say, open my skeleton for dog, I'm gonna search for ankle points. So we have these ankle points. So I'm gonna call these forward legs to right hand, right leg, forward leg, left leg. So first we will select our right hand. This is the ankle point of my right hand. Copy the name and add it to the bone over here. And for my origin bone, I'm gonna select my right hand and right leg. This will be my right leg. And set it over here, right leg, like so. So we have set up our right hand and right leg and set the weight to 1. And similarly for my other position, for the remaining 2 legs, I'm gonna duplicate the same, set the color to yellow for the second one. And for this one, I'm gonna select my left hand, copy the name, paste it over here. Left leg, there we go. Yes, this one, left leg over here, like so. Set the weight to 1. And now the third thing, we have 2 position channels now. Now we need a third one for our velocity. We will check our velocity of our pelvis bone, and based on that we will select the right animation from the database. Now, like blending from walk to trot to run, so that blending can also be fine. So I'm going to select the velocity channel. Right, I'm going to set the color to white. So the velocity will be, I'm gonna grab my pelvis velocity for this one. So we only are working with our locomotions. We are currently not dealing with the jumping and stuff like that. So we need the velocity in XY axis only. So I'm gonna strip the component Z, so that we are only carrying our velocity in X and Y axis. Okay, so our schema is almost done. We have our trajectory channel with 5 samples, and we have our 2 position channels, which are right leg, right hand, left leg, and left hand, and our velocity channel for our pelvis. So for my velocity channel, I'm gonna set the weight to, let's say, 0.5. So we are taking more weight from our position channels and less weight from our pelvis velocity channel. So our schema is done. Now let's go to our database, post search database. I'm gonna grab my animation. Sorry, I will search for, we will need a root motion animation. So here we have this loco walk. Place it over here. There we go. Now you can see the animation is appearing in the viewport. So sometimes it happens. So if animation is not appearing, maybe you need to close the editor and run it again. So here we have our position. Let me just double check my notes. Yeah. Okay. So we have our movement database, which will contain our loco walk, trot, and run. I'm gonna grab my trot animation as well. Loco trot. Loco trot. Yeah, this one. So this animation also have the root motion. Yeah, and now we need also run, loco run. So make sure your all the animations have root motion, and set all the animations are set to looping. All right. So if we select our one of the database, you can see we have our trajectory channel. This is the point at negative 0.50, 0.1, 0.2, sorry, 0.1, 0.3, and 0.5. So these are our trajectory channels. The green one is our position channel for right hand and right leg, and the yellow position channel is our left leg and left hand. So now we need to set up the continuous post bias condition. So currently you can see this tell us that this is useful. So if we set this in short, if we set this value to lower number like negative numbers, the motion matching will most likely to stay in a single animation, like it will not jump into multiple animations. So by the way, I have already covered all these properties in details in my breakdown motion matching tutorial series. So for this video purpose, I'm set it to minus negative 1 only, negative 0.1, sorry, so that our motion matching prefer to remain in a single animation instead of jumping into multiple animations. So our movement have these animations. Movement database contains these 3 animations, and we need a normalization set as well. So we will create a normalization set as well. Animation. You can skip this normalization set if because we are only dealing with like 3 or 4 animations. But if you are dealing with like a huge set of animation databases like starts, stops, pivots, spin rotations, like then you need to set your post search normalization as well. But for this, I'm going to set it to post search normalization for quad default. So it's just simply you need to put your database over here. So we currently have one database. We will need an idle one as well. So this is our first database done. We will set the normalization set over here as well. So now we need a new database for our idle. For search database, select the schema will be our post search database for quad idle. Okay. So for this one, I'm gonna go to my animations folder, animation. We have the idle. We should have idle animation in place. Idle. Sorry. We should have a stand. Yeah, stand 0, 0. Where is our idle animation? Stand 0 0. Yeah, this one. So this is the animation which is set to looping and has the motion. So this is our standing animation. I'm gonna put it over here like so. Set the normalization set. So normalization set, we have also created a new database and we will put it over here as well. So we have two databases, movement and idle. We will put these two databases in our normalized post search normalization set, and these are our two databases. So our post search schema and databases are done. Now we need to use the motion matching node in our animation graph to select to perform the motion matching with these animation, and now and also we need to select the chooser so that we can blend between our idle to walk. So now let's set that up, guys. So now I will go to my animation blueprint, open my animation blueprint, and so first thing we need to find out our locomotion state, which either we are in walk, run, trot, or idle state. So which locomotion state are we in? So in order to find that out, we will set this up in our character blueprint. Okay, so I'm gonna create a new enum blueprint enum e_locomotion state. There we go. So we have 4 different states. Either we are in idle, walk, trot, or run state. So this is done. Now we will set up our locomotion state in character blueprint. Select the type to e_locomotion state. Yeah, there we go. So find locomotion state. We will create a new function, find locomotion state. Find locomotion state. Right. So we already have our input axis. Like, let's say we grab our input vector. We already have this input vector. If our input vector length is less than or equal to 0, like, then we are in idle state, which means like if we don't have an input, we are in locomotion idle state. That's it. But if we do have some input, we will need to decide which state are we in, like either we are in walk state, run state, or trot state. So in order to do this, I'm gonna create separate functions switch to walk, like switching between different states. So I'm gonna create a new function, switch to walking. There we go. Switch to walking. And first, like inside all these functions, we need to first set up our set max walk speed. Like what should be our max walk speed when we are walking, like mean analog speed as well, mean analog speed, analog speed walk. And also we need to set the braking deceleration walking, set braking deceleration walking, this thing. And also we need to set our locomotion state to, let's say, we also need to set up our interrupt speed, which we have created in our part 1. So this is the interpolation speed. We also need to change this for our different locomotion states. Like walk can have different rotation speed, run can have different and trot can have different speed. We need to also change it for each state. So for walking, first I'm going to set the max walk speed to 80 because our animations have this at 80 speed. If I go to my animation walk, yeah, we can see we have the move data speed at 80. So for when we are walking, our walk speed should be 80. 80. Breaking deceleration walking, I'm going to set it to 500. Movement interrupt speed. For the walking, I'm going to set it to 120. For interpolation speed for rotation, and set the locomotion state to walk as well, like so. So what I'm going to do is also I'm going to change my camera length so that when we move, we have a dynamic, like our camera length also changes. So like let's say when we are walk, run, trot, our spring arm length also changes. So we can also change it based on our different functions, like when we are in walking or run and sprint. So I'm gonna set a new variable, spring arm length. This will be our float. So for walking, will need the length to let's say 230. So our function is done. Like switch to walking, I'm going to duplicate the same function, switch to trot, and we need to select our animations. Sorry, the speed. If I'm going to search for loco trot. There we go. So we need to find out the speed. What we can do is motion extraction modifier. Select the rig root root. We need to set the speed, translation speed in XY axis, and we need a curve for move data speed. Apply. So our trot speed is 300, almost 300. So we will set our max walk speed to 300, like so. I'm going to set the deceleration walking to 1200. Interrupt speed, I'm going to set the interrupt speed for my trot to 180. Spring arm length, I'm going to set it to 275, let's say, and locomotion state to trot. Now we need to switch to run. For run, what is our speed? Loco run, this one. Motion extract modifier, rig root, speed in XY, translation speed, and curve name should be move data speed. So our run speed is 862. So I'm gonna set the run speed to 800. Switch to run, our max walk speed is 800. Breaking deceleration walking, I'm gonna set it to 2000. And our interpolation speed, I'm gonna set it to 250 for now. Our rotation interrupt speed, and for the spring arm length, I'm gonna set it to 320, and set the locomotion state to run. So these are our three functions are done. Now we need to change between all these states. So we have our find locomotion state function over here. Find locomotion state, I'm gonna call it attic find locomotion state. So if we have the input, what we'll do, if we don't have the input, we will set our locomotion state to idle. But if we have the input, we will decide like if I will switch based on different keys. So I will set the debug key 1 for my walk, debug key 2 for trot and debug E3 for my run. What I will do here is create a new variable locomotion state underscore input. So when I press 1, our locomotion state should be walk. When I press 2, locomotion state should be trot. When I press 3, locomotion state should be run. Okay, and the default value I'm going to set it to, like, let's say walk. So now inside our find locomotion state, what we can do here, if we have some input, we can do check our input, locomotion state input, and add a switch, like idle can be idle. So when we are in walking state, we will switch to walking. When we are in trot, this state trot, we can switch to trot, and similarly we can switch to run. There we go. So now our different locomotion states are done. Now let's test this in our level. So by default walk, if I press 2, we are switched to trot. Press 3, we have switched to running. And we need to use this information in our locomotion, in our animation blueprint. So now let's set up our animation blueprint. Okay, so we already have created a reference to our character. So what we will do is, if our character is valid, we will use access, property access, and go to our character, find locomotion state, and we will print our locomotion state. Here you can see idle, walk, press 2, trot, run. Now we can see based on 1, 2, 3 input keys, we can switch to walk, run, and trot state. So this input is done. Now we need to create a new function, update states. I'm gonna create a new function, update states. So I'm gonna grab this. So this will be our locomotion state inside our animation blueprint, locomotion state. So we need our last I will need a last locomotion state as well. I'm going to duplicate the same variable, last locomotion state. So last locomotion state will be our current locomotion state, and current locomotion state will be set when we will be set from our character blueprint. So now we need to call this function from a thread save. I'm going to select this function, set it to thread save to true, call this function, and now when I hit play, I will debug my locomotion state inside from animation blueprint. Now you can see we can walk, trot, run, walk, trot, run. Okay, now we will use this information inside a chooser, and then we will decide which database to pick. So if our locomotion state is idle, the chooser will pick our idle database. If the locomotion state is, like, let's say walk, trot, run, chooser will pick our movement database. So that is done. Now let's set up our chooser and motion matching. So now we need to add a new node, motion matching. Motion matching node over here. So okay, I will move it slightly or a bit. Motion matching node, we need to set up this. So first thing first is, I'm gonna just let me go to my nodes. So the database should be a dynamic value. I don't want to expose this. Database will be a dynamic value. Blend time. So for blend time, what I will do here is, instead of putting a hardcode value, what I will do here is I'm gonna create a new function, motion matching blend time. So when my locomotion state is, I'm gonna use a return for float, return value, and select based on this my locomotion state. So if my locomotion state is equal to idle, like when we are blending from movement to idle state, we want a different blend, and when we are blending from idle to movement, we want a different blend. So we need to do this. I'm gonna go to blend time. So when we are in idle state, we want a blend to 0.5, and we start moving, we want a blend time to 0.35. I'm gonna set this function to pure, set this to thread safe. So now we can call this function to our motion matching node. So blend time, we will set our motion matching blend time dynamic value. Blend profile, just remain it as it is, and pause, reselect, like set these to default values, all these to default values. Let me double check. Yeah. And for play rate, so let's say our speed is 500, but the animation speed is 450. So we can change our play rate based on this. So we can minimum play rate should be 0.75, maximum would be 0.25. So we can increase our play rate 25% and decrease our play rate to 25%. So play rate is done. We don't want initial blend, and yeah, that is it. These are all the properties which we need. Now we need to select our database, which database to choose when motion matching updates. So we need on initial update, on motion matching initial update. Let me. So we need create a new function, create binding on update underscore motion matching. So this function will run at every frame when our motion matching node is executing. So we are calling this function from here on update. So what this function will do, this will evaluate our chooser first. Evaluate chooser. So first we need to create a chooser. Now I'm gonna go to my database content browser. We need a chooser. I'm gonna select animation chooser table. So we need an animation chooser, and for the which animation class we need it for animation blueprint dog. Create one chooser table. I'm gonna call this cht underscore quad pose search. So this is our chooser table. All right. So inside our details panel, we have output parameters. We only want class parameter. We don't want struct parameter to be output. We can delete this. And animation assets. So let's say if I had a new row, add an asset, you can see I can add animation assets like montages, sequences. I don't want that. I want only to select my pose search databases. That's it. So I will go to my details. I'm gonna set the result class to always pose search database. Now when I add a row asset, you can see I can only pick from idle or movement database. So our first row should be our idle, and based on which condition, we already have a enum in our animation blueprint. See, this locomotion state is already, enum is already there. So I'm gonna add a new column for that enum, our locomotion state. So if our locomotion state is idle, select the database idle, duplicate the same. If our locomotion state is, let's say, walk, trot, if our locomotion state is let's say walk, set this to movement. Yeah. All right. So now let's find run our chooser, evaluate chooser. We have a chooser, find result. We want all results from a chooser. Anim instance, self, cause reference to self, and from this is motion matching. Now we will motion matching, convert to motion matching node, and from this node we will set database, set databases to search, databases to search. So these are the output databases, and these from these output databases, motion matching will pick the right animation based on the QD. Like QD contains our trajectory, our position channel, our velocity channel. So this is all the QD. Motion matching will run this QD and then pick the best animation, pick the suitable and most suited animation from the chooser table. Currently you can see if I deselect this node, you can see my character is in wait, okay, if I go deselect this, you can see this is in the default state, this skeleton mesh. If I connect this will remain in this state, and now when we evaluate chooser will be evaluated, and then when we from the chooser result we pass that result to set database for motion matching, and see it immediately goes to the idle state because we don't have any input, we don't have any trajectory. So this is the most suited animation which motion matching have picked for us. So interrupt mode, we need to set this up. So interrupt mode is pretty useful, and we need to give proper attention what our interrupt mode should be. So do not interrupt. So this mode will so I have already explained these modes in my breakdown motion matching tutorial series already. So what we will do is do not interrupt. What we'll do is it will keep playing the current animation and then blend towards the next animation when the results are properly suited. Like let's say we are running, we immediately stop input and we need to go to the input idle state immediately. If we set this to do not interrupt, it will keep playing the run animation and then gradually blends into the idle animation. It will not immediately blend towards the idle. We don't want that. We want a dynamic behavior. Like let's say when our locomotion state is already moving, we want to remain in the preferred state. But when our locomotion state becomes idle, we want to interrupt our current database immediately and blends into the idle state. So I'm gonna create a new function, get database motion matching interrupt mode. So this will be our return mode. I'm gonna set this to the output should be our post search interrupt mode. Type will be E, pause search. So what I will do, I'm gonna promote it to variable, delete the variable from here. The output type will be I'm gonna grab this interrupt mode and paste it over here. This will be an easier way to set the reference, set the output type. So our output type will be interrupt mode. I'm gonna set this to call this to return value. So we need to select our interrupt mode. Select. So when our locomotion state is equal to last locomotion state, like when our when our locomotion state is not equal to last locomotion state, which means we have switched like from idle to move to idle. When this happens, we want to interrupt our database immediately. And when our last locomotion state becomes equal to current locomotion state, which means we are already in a movement state, we don't want the database to change immediately. We will set this to do not interrupt. And now when I'm gonna set this to thread safe and pure. I'm gonna grab it over here and set my interrupt mode this. So this is our motion matching function is set up. Motion matching node is here. On update function, we are evaluating chooser. Chooser will give us the output for our database, and that database goes to the motion matching to search, and this will output the desired pose. So now fingers crossed, and now let's hit play and see what is the result. There we go. And you can see we are in walk state. And when I press 2, 3, we cannot go into the run and trot state because we have not set that up properly. So first thing is I'm gonna go to my user table and see what is wrong here. Okay, so we cannot select multiple states because we have select this enum. We have not set this properly. So if I select this enum, or you can see if I go to locomotion state, now I can select multiple states. So when we are in idle state, we pick idle, and when we are in walk, we are in trot, we are in run, we can select this same database. So this is the enum we have already added, which cannot be an or condition. So I'm going to delete this, and now based on this enum, we can, when we are in walk, trot or run state, we will select the same database. So now when I hit play, see, I can switch to trot, run, and you can also notice that our blending is also working fine. Actually, I'm gonna lower my this skeleton mesh to -8. It's still like, let's say, call it to -93. Yeah, now it's fine. No, let's change it to -92. Okay, so now we can see our motion matching is functional. We can switch between walk, run, and trot states. And now we need to set up our additional support from animation blueprint, so that let's say so that when we move, we can add an additive animation, and like our procedural lean or our additive movement in our direction where we are heading, as you can see in the current one. So we will set this up remaining functionality in the next one. So yeah, that's it for this video, guys, and I will see you in the next one.